So if you have the series in the arithmetic progression form, we write it as n by 2, 2 into a plus n minus 1 into d. Let us apply the summation on both sides. Summation of a n term is nothing but Sn, and here we can take 1 by 6 outside. Let us apply the summation separately. No series in terms of numbers or n is given. They have given the nth term. We are supposed to calculate only the summation. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we will be studying about the summation of n terms of a special series. What are the special series? We have learned the arithmetic series and geometric series based on the arithmetic sequence and geometric sequence. That is summation of those arithmetic sequence and geometric sequence using the formulas. Here we have some special series. Here we have already taken the nth term and we have already found the Sn term. That is, what is the general formula to find the summation of the given series. Basically, here we are considering three types of special series. The first is, it is of the form 1 plus 2 plus 3 plus etc. n. When you add all the n natural number, what is the summation? That is, the summation from 1 to n k terms is given by the formula n into n plus 1 by 2. That is, summation of n terms is given by n into n plus 1 divided by 2. The next one we have sum of squares of the first n natural number. So you have first n natural number, square it, add it. 1 square plus 2 square plus 3 square etc. until the last sum, that is n square. So we have already generated the formula using the nth term. So what is the formula for summation of natural numbers? When you add the squares of all n natural number, it is given by the formula n into n plus 1, 2n plus 1 divided by 6. The next one, we have a special series of cubes. That is, adding all the cubes, natural numbers from 1 to n. 1 cube, 2 cube, plus 3 cube, plus etc. plus n cube. So what is the formula for this? This is given by n into n plus 1 by 2 whole square, or n square into n plus 1 whole square divided by 4. So these are the three basics formula which we are going to use for the problems next. So these are considered as the special series. All these formulas are deduced using mathematical induction. They are proved from the method of mathematical induction, which we will study later. So learn the formula for summation n square and summation n cube, or k square, k cube, where k varies from 1 to n. Let's see the first problem here. Find the sum of n terms of the series 5 plus 11 plus 19 plus 29 plus etc. So we have here the numbers as 5, 11, 19, 29, 41. So let us take here Sn is equal to 5 plus 11 plus 19 plus 29 plus 41 plus the last but one term as a minus 1 plus an. Next again I will take Sn. I will take here as 0 plus 5 plus 11 plus 19 plus 29 plus 41 plus etc. plus an minus 1 plus an. So let me subtract here. So I will get this as 0, 5 plus 6. So next we get it as 8, 10, 12, etc. until n minus 1 terms along with an. So now let me separate this. So here we have a sequence of even numbers, that is 6 plus 8 plus 10 plus 12, etc. until n minus 1 terms. So, we'll change the sign minus. We will shift an here. Then it is an is equal to 5 plus 6 plus 8 plus 10 plus 12 until n minus 1 terms. Let us take summation an now. Summation an is nothing but summation 5 plus summation of these series. So, if you have the series in the arithmetic progression form, we write it as n by 2, 2 into a plus n minus 1 into d. But here in the place of n, we have n minus 1. So, we write it as n minus 1 into 2 into 6 plus n minus 1 becomes n minus 2. Difference is 2 whole divided by 2. So, when you solve this, it becomes 5 plus n minus 1 into n plus 4. So, again, by multiplying this and adding 5, we will get the term as n square plus 3n plus 1. So, this is what we got now. So, we have got the series in this form now. So, let's take this as nth term and apply the Sn here. So, let me apply Sn here. Now, Sn is equal to summation of what we got the series as. I'll take this as k square plus 3k plus 1. K varies from 1 to n. Now, I'll apply the series or the summation separately. I'll take this as summation k is equal to 1 to n k square plus summation k is equal to 1 to n 3k plus summation k is equal to 1 to n 1. Now, what is the formula for summation k square? So, it is n into n plus 1, 2n plus 1 divided by 6. And here we can take 3 outside. So, this is n into n plus 1 divided by 2. And here we get it as 1. So, on solving this Sn, take n into n plus 1 outside. What we are left with is 2n plus 1 divided by 6 plus 3 by 2 plus 1. So, let us solve this now. So, on solving, we will get the Sn term as, first solve this fractions. When you solve this, we will get the answer as n into n plus 2, n plus 4 divided by 3. So, this is the nth term of the given series. So, the next question, find the sum to n terms of each of the series. We have the series in the form of 1 into 2, 2 into 3, 3 into 4, 4 into 5, etc. Let's find the nth term now. Nth term, you can clearly see if this is n plus 1. For example, 1, 1 plus 2, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1. So, if you have nth term as n, then it is n plus 1. So, nth term we can recognize it as n into n plus 1. So, which becomes n square plus n. Now, let us apply the summation, that is Sn. Sn is equal to summation k from 1 to n k square plus k. So, if you apply the summation separately, it is summation k is equal to 1 to n k square plus summation k is equal to 1 to n k. Now, we know the formula for k square and k. So, this is n into n plus 1, 2n plus 1 divided by 6 plus n into n plus 1 divided by 2. Let's take n into n plus 1 by 2 outside. We are left with 2n plus 1 divided by 3 and here we get 1. Next, When you solve this, n into n plus 1 divided by 2. 3 when it goes to there, it is 3. 2n plus 1. Again you will get it as 4. So you can take there 2n plus 4 divided by 3. Again, if you take 2 as a common factor there, you can remove it. 2 and 2 get cancels. You can write this as n into n plus 1, n plus 2 divided by 3. So this is the summation of the series given 1 into 2 plus 2 into 3 plus 3 into 4, etc. Next we have 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5, etc. Let's see now. Clearly, if this is 1, this is 1 plus 1, this is 1 plus 2. If this is 2, this is 2 plus 1, 2 plus 2. Similarly, if you have n term, then it is n plus 1, n plus 2. So therefore, an we will get it as n cube plus 3n square plus 2n. Let us apply the summation here. Summation an, this can be written as summation k varies from 1 to n, k cube. Summation k varies from 1 to n. You can take 3 as a constant which keep outside, plus summation k into 1 to n. You can take 2 outside n, k. Now we know the formula for all these special series. Let us apply it. It is n square, n plus 1 whole square divided by 4, 3 into n plus 1 into 2n plus 1 divided by 6 plus 2 into n plus 1 divided by 2. From all this, we can take n plus 1 by 2 as a common factor. So, n plus 1 divided by 2. So, here we are left with n into n plus 1 by 2. And here we are left with 3 1s are 3 2s are. If we take 2 common factor, we will get 2n plus 1. And here, so if you take 2 as a common factor, n into n plus 1, you are left with 2. So again, on solving this, so again you can take n into n plus 1 divided by 2 into, you will get this as n square plus 5n plus 6 divided by 2. So multiply 2 here, you will get it as n into n plus 1, n square plus 5n plus 6 divided by 4. Or if you split the term, you will get Sn as, here we are doing Sn, which is n into n plus 1, n plus 2, n plus 3 whole divided by 4. So this is the summation of the given series. Next we have 1 over 1 into 2 plus 1 over 2 into 3 plus 1 over 3 into 4 plus etc. So here an term, clearly this is in the form of 1 into n, 1 by n into n plus 1. So what I'll do here, I'll add n plus 1 and here minus n divided by n into n plus 1. So I can rearrange and write this as here 1 by n minus 1 by n plus 1. Let's take the terms now. A1, it is 1 minus 1 by 2. A2, it is 1 by 2 minus 1 by 3. A3, it is 1 by 3 minus 1 by 4. So, till the last term an, it is 1 by n minus 1 by n plus 1. Now, summation is nothing but adding all the terms. So, a1 plus a2 plus a3 plus etc. an. is nothing but Sn. So when you add all the terms, you can clearly see minus half plus half, minus 1 by 3 plus 1 by 3, minus 1 by 4, again we'll get plus 1 by 4. The previous minus 1 by n cancels with the plus 1 by n. So we are left with Sn is equal to 1 minus 1 by n plus 1. So on solving, we get this as divided by n plus 1 cancels. This is in the form of n by n plus 1. So therefore, the summation of the given series is n divided by n plus 1. So why I have done this method means, so here it is in the denominator form. Even though if you get n square or n cube form, so you have to rearrange the term, multiply it. So this is the simple way we found, and we are doing this. So addition is nothing but the summation. So we can directly get what is the nth term or the summation of n terms of the given series of this form. Next we have 5 square plus 6 square plus 7 square plus etc. 20 square, like that. So we know the summation for k square, that is from 1 to n. So what we are missing here is, so this can be written as 1 square plus 2 square plus 3 square plus etc. until 20 square minus 1 square plus 2 square plus 3 square plus 4 square. This can be written like this. Now what is this actually? So this is when you take the summation of n to 1 to 20, that is n square. And this can be written as summation n from 1 to 20 n square. And here it is 4 because we have only 4 terms. Now let us apply this. What is this formula for n square? We can write this as summation 20 square minus summation 4 square. We know the formula as n into n plus 1, 2n plus 1 divided by 6. Here the values are given in terms of numbers, not in terms of n. So we will get the value in numericals only. So summation 20 square means 20 plus 1. 20 into 2 is 40 plus 1 divided by 6. And here we get 4 plus 1, 8 plus 1 divided by 6. So when you multiply this, you will get this as 2870 minus 30. Therefore, Sn. So from here we have doing Sn. You will get this as 2840. So this is the value for the given series. Next question. 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square, and the last term we can guess it as 1 square plus 2 square plus 3 square until n square. So therefore the last term an is 1 square plus 2 square until n square, which we can write this as n into n plus 1, 2n plus 1 divided by 6. So therefore an is, multiplying this and dividing by 6, we get this as 2n cube plus 3n square plus n divided by 6. Let us apply the summation on both sides. Summation of an term is nothing but Sn, and here we can take 1 by 6 outside. Let us apply the summation separately. We can take 2 outside, summation n cube. We can take 3 outside, summation n square, summation n. Now Sn is equal to 1 by 6. Here we have 2. Summation n cube means n square, n plus 1 whole square divided by 4. And here it is n into n plus 1, 2n plus 1 divided by 6. And here it is n into n plus 1 divided by 2. So you can cancel here 2, 2. So from all the terms you have 1 by 2 as a common factor, n and n plus 1 as a common factor. So therefore Sn is equal to n into n plus 1 common. 1 by 2 is common. When you multiply, it becomes 12. So here you are left with n into n plus 1. Here 2n plus 1 plus 1. Multiplying and solving this can be written as n square plus 3n plus 2. So only this value on solving we can write it as n square plus 3n plus 2. But n square plus 3n plus 2 can also be splitted into two terms as n plus 1 and n plus 2. So therefore, here Sn can be written as n into n plus 1, one more n plus 1 into n plus 2 divided by 12, or we can write this as Sn is equal to n into n plus 1 whole square into n plus 2 divided by 12. So this is the summation of the terms of the given series. So to find these type of summation of the special series comes under the last part, that is part E, as a sub question in part B. So you will have 10 marks question which is in the form of 6 plus 4. So the 4 marks question contains the summation of special series from the chapter sequence and series. So these type of questions carries 4 marks on 49th B or 50th B as a sub question for 10 marks in your examination. Now till here they would give you the series. We have to find the nth term. Later we used to find the summation. So here they have already given the nth term. No series in terms of numbers or n is given. They have given the nth term. We are supposed to calculate only the summation. So let's see now. If this is your an, so multiply this, you will get an is equal to n cube plus 5n square plus 4n. Apply the summation. Summation if an is nothing but Sn. So summation n cube, 5 you can take outside, summation n square, 4 you can take outside, summation n. So this is n square plus n plus 1 whole square divided by 4, 5 n plus 1, 2n plus 1 divided by 6. Here it is n into n plus 1 divided by 2. So you can take n into n plus 1 by 2 as a common factor. So then you are left with n into n plus 1 by 2. Here you have 5 into 2n plus 1 plus 1. On solving this, you will get the value as n into n plus 1 divided by 2. And here you can write this as n plus 2, 3n plus 17. So this is the summation of nth terms of the given term. Next, we have n square plus 2 power n. So let us apply the summation. If this is n square plus 2 power n, when you apply the summation, it becomes Sn. Here summation of n square and here summation of 2 power n. So 2 power n means 2 power 1, 2 power 2, 2 power 3. This is in the type of geometric progression. Now here n square can be written as n into n plus 1, 2n plus 1 divided by 2. So 2 power n can be written as 2 into 2 power n minus 1 divided by 2 minus 1. So n into n plus 1, 2n plus 1 divided by 2. Here you can write this as 2 power n plus 1 minus 2. So this is the nth term of the given series. Because here 2 minus 1 is 1. 2 into 2 power n can be written as 2 power n plus 1. Minus 1 into 2 becomes minus 2. Next we have 2n minus 1 whole square. When you expand this, this is 4n square minus 4n plus 1. So this is expansion using a minus b whole square formula. So now let us apply the summation for this. This is Sn is equal to 4 summation n square minus 4 summation n plus summation 1. So 1 n times becomes n. So it is 4 into n plus 1, 2n plus 1 divided by 6 minus 4 into n plus 1 divided by 2 plus n. So here 2's are 3's are 2 2's are. Now let me take n by 3 as a common factor. Here I am left with 2 into n plus 1 into 2n plus 1. And here if I take n as a common factor again and 3 as a common factor, here I am left with 2 3's are 6 n into n plus 1, and here I am left with 3 n I have taken as a common factor. So this is, let us solve this. So n by 3, multiply, expand and solve. So you will get the equation as 4n square minus 1. Now this is in the form of n by 3, 2n whole square minus 1 square. That is a square minus b square. So therefore Sn can be written as n. A square minus b square can be written as a minus b, a plus b. So this is 2n minus 1, 2n plus 1 whole divided by 3. So this is the formula to find out the summation of the n terms of the series of the form 2n minus 1 whole square. Next we have n into n plus 3. So when you multiply, it becomes n square plus 3n. So clearly Sn can be written as summation n square plus 3 into summation n. That is n into n plus 1, 2n plus 1 divided by 6 plus 3 into n plus 1 divided by 2. So we can take n into n plus 1 by 2 as a common factor. So then we are left with 2n plus 1 divided by 6, and here we are left with 3 into n plus 1. So now here let me take n as a common factor, n plus 1 as a common factor and 6 as a common factor here. So therefore here I am left with 2n plus 1, and here it becomes plus, I have taken 6 as a common factor. So here it is 9, n into n plus 1 I have taken outside. So this is the answer. So now here n into n plus 1, this becomes 2n plus 10. So again 2 if I take as a common factor, I will get n plus 5 divided by 6. 2 1's are, 2 3's are. So therefore the equation or the term is n into n plus 1 into n plus 5 divided by 3. So this is the sum of the series of the form n into n plus 3. This is all about the chapter, the sequences and series, that is the arithmetic and geometric progressions of a series and the sum of n terms of a special series. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning and keep exploring. Thank you.